Let's return to our data set of personal income in the United States. So far, we've looked at sort of the typical observation in this set of observations, meaning we've looked at measures of central tendency. So we have a good idea where the median, the mean, and the mode income lies in this set of observations. We also have an idea about measures of location or position. So we know what incomes are for the bottom and top percentiles in this set of data points. But we also want to know how varied, how spread out these incomes are. Especially a lot of sociologists and economists, when they're looking at income, it's not only useful to have some measure of central tendency or measure of location, but you often also want to know how varied people's income really can be in different societies. So let's step back and think about what it means to talk about variation or variability in a set of observations. These measures of variation, they're also called measures of spread, dispersion, or variability. That all means the same thing. You're just looking at how spread out a set of data points are. The mean, median, and mode, these measures of central tendency, they give us information about a typical set of observations, what the typical value is in a set of observations. But they don't tell us much about the dispersion or spread. So you might ask, okay, we have these two small data sets. We have one data set that consists of the number 5 repeated 5 times, and then we have another set of observations that consists of the values of 1, 3, 5, 8, and 8. These are two separate small data sets. Now looking at these two sets of data, you might say, okay, which sets of observations has greater variability? Which one is more spread out? Which one has more variation? If you talk to most people, they will say, well, the second set of observations has more variability. The first set of observations, there's no variation because the numbers are all the same. It's 5, 5, 5, 5, 5. 5 repeated 5 times. However, if you look at measures of central tendency, you'll see that for both of these data sets, the mean is 5, and for both of these data sets, the median, or the 50th percentile, is also 5. In a similar fashion, if you look at the mode, it differs somewhat, but the mode is still not giving you much information about how spread out these two sets of observations are. So how do we look at how spread out a set of data points can be? Because these two small sets of observations, they really are different in terms of their variability. So we want a measure of variation. The simplest measure of variation in a set of observations is the range. The range is simply the difference between the largest and smallest values in a set of observations. To put it another way, you take the maximum x value and then you subtract the minimum value from that maximum. Let's look at a few examples. If you have a set of observations of 1, 2, 3, 4, and 5, the range is 5 minus 1. So the maximum value is 5, the minimum value is 1, so that a range is 4. You take the maximum value and you subtract out the minimum value. But let's look at a set of observations when that last number is, instead of being 5, is 10. So it's really kind of an extreme value or an outlier. In that case, the range is the maximum value, 10, and the minimum value, 1, and it's the difference between those two. So 10 minus 1 is 9. So the range differs depending on the maximum and minimum values. That is a relevant point, however, because one problem with the range is that by looking at those two endpoints, it's neglecting the data within the range. So since the range is based on the two maximum and or minimum values, it's those two endpoints, there could be variability within that range, those two endpoints, that is effectively ignored. So for example, if we have a set of observations of 1, 2, 2, 2, and 5, the range is 5 minus 1, or 4. But suppose instead of those three values of 2, we have those three values of 5 for that middle part of the set of observations. Then the range is still 5 minus 1, or 4. So those two sets of observations, they're really quite different in the sense that the first set of observations has more variability because you have values of 1, you have values of 2, and you have values of 5, whereas the second set of observations, you simply have values of 1 and 5. So the range is ignoring the distribution of data within the range. Another problem with the range, and it's related to this first point, is that the range is sensitive to outliers or extreme values. So for example, suppose we have a set of observations of 1, 2, and a bunch of 3s. The range is going to be the difference between the maximum and minimum values. So the maximum value is 3, the minimum value is 1, so that range is 2. However, let's just suppose we just change one of those values to, say, 95. Well, the range is going to be 95 minus 1, or 94. The problem with this is that you can see that that's not that big of a difference between these two sets of observations. You're just changing one data point. You're just changing one observation. Yet the range changes from 2 to 94. So the range, by being based on two data points, effectively, the maximum and minimum values, it is sensitive to those extreme values or outlying observations. So let's return, now that we know something about the range, to our data set of personal income in the United States. We have an idea about the mean, the median, and the mode, but let's look at the maximum and minimum values and then calculate the range. The maximum value in terms of income is about $1 million. The minimum value is about $0. So if we take that difference, you can see that the range is a bit over $1 million. And that range really reflects a great deal of variability. Meaning if you look at that number for the amount of variation in the data set, somebody will say, well, that is a ton of variation. You know, considering that the median income is $23,000, the mean income is about $37,000, that range of over $1 million, that is a lot of spread. That's a lot of dispersion. That's a lot of variability. But the problem is that that measure of variation or spread, that might be based on only one person. That's because the range is sensitive to outliers. So suppose in our data set, there's really just one person making over $1 million, and then everybody else is around the mean, the median, or the mode. This measure of variation or spread, it's going to be misleading, and that's because the range is not robust. It is sensitive to extreme values. So we need a measure that is more robust, that is insensitive to these outlying points. That measure of variation that is robust to outliers is called the interquartile range. The interquartile range is simply the third quartile minus the first quartile. So when you have a set of observations, a set of data points, and you organize those data points from lowest to highest, and then you calculate the percentiles, that middle 50% of the data, that difference between the 75th percentile and the 25th percentile, that is known as the interquartile range. You're basically looking at the range of the middle 50% of the data. And by ignoring the top 25% of the data and the bottom 25% of the data, you are eliminating many extreme values or outlying values that would really might make your range as a measure of variation misleading. So let's look at an example in terms of personal income. So if we look at our summary statistics, the third quartile is about $48,000 and the first quartile is $8,600. You look at the interquartile range, it's $48,000 minus $8,600, which gives us a value of $39,400. So you can see that as a measure of variation, the interquartile range is much smaller than the range. The range was over $1 million. The interquartile range is about $39,000. So the interquartile range is giving us an idea of, instead of looking at the entire set of observations, it's saying how different is the 75th percentile from the 25th percentile? How different is the set of observations when you're just looking at that middle 50%? And you can see that the variation, as a measure of variation, is just much smaller. And that reflects the fact that we're not looking at these extreme values, these outlying points. And so the interquartile range, it can be a more effective measure of spread or variation when you suspect your data set does in fact have outlying values.